So, our second lesson for Module 7, which is Lesson 7.2, we're going to be writing and solving two-step equations of the format P x plus Q within parentheses is equal to R. And if I look at my learning target, I can write two-step equations of the form P within parentheses x plus Q is equal to R, and use inverse operations to solve the equations. We're going to do a couple of methods, and two of them that I am going to stress on is the distributive property method and using the properties of equality, which would be either addition property of equality, subtraction property of equality, multiplication property, and the division properties of equality. So we are going to be using the inverse operations, which we have learned in the past. Okay, so the vocabulary that we must know in this lesson is distributive property. And distributive property is nothing but the number which is written outside the parentheses needs to be multiplied with each term that is inside the parentheses. So, for example, if I have this number over here, the 3 and 5 plus 4 within parentheses, I would basically take this number which is outside the parentheses and I would multiply with each term inside. So I would do 3 times 5 plus 3 times 4. And I know that 3 times 5 is 15 plus 3 times 4 is 12. And then if I look at 15 and 12, I get 27. So this is basically how distributive property is done. So I was just reviewing that vocabulary. Now let's get started with writing and solving two-step equations in this format. So we're going to start with the distributive property method first. Okay, we'll start with the distributive property method first. And basically, what am I doing? As I said earlier, I am multiplying the term outside with each term inside. So 3 times x plus 3 times 2. And 3 times x is going to give me 3x plus 3 times 2 is 6 is equal to negative 18. All right. So once I have this, we are going to look at, remember we talked yesterday that in two-step equations, we go in the reverse direction of order of operations. So instead of multiplication, we are going to be doing this part first with plus 6. So the opposite or the inverse of plus 6 is going to be minus 6. So we are going to use the subtraction property of equality, and we are going to subtract 6 from both sides of the equation, because whatever I do on one side of the equation, I've got to do exactly the same thing on the other side of the equation. So if I do minus 6 over here, because it's a balance, it's an equation, I'm going to do exactly the same thing on the other side. Okay, so now when I look at this, I have 6 minus 6, which is 0, and I have 3x, and then I can look at negative 18 and plus negative 6, because these are the same signs, all right? And so remember, when we had done integers, you just add the opposite. So this is going to give me negative 24. This gives me negative 24 because the same signs, okay? And then I'm going to look at this, and now this is a one-step equation, and I have the coefficient and the variable, that means multiplication, and the inverse operation of multiplication is division. So I am going to divide both sides by 3. Both sides by 3. Okay, and 3 divided by 3 gives me 1, and 1 times any number is the number itself, so 1 times x is going to give me x. And then negative divided by positive, I'm going to get a negative quotient, so negative, and 24 divided by 3 is 8. So x is equal to negative 8. Okay, so this is the distributive property method. And of course, we can check our answer by substituting the value of negative x, of negative 8 into x, and then solving it. We will end up with exactly the same answer. Okay, so let's go and look at the properties of equality in order to solve this problem. And in this one, as we can see, this means multiplication, right? We are multiplying 3 with each of these terms. So I know the opposite of multiplication, or the inverse operation of multiplication, is division. So I am going to divide both sides by the same number to keep it a balanced equation. Okay, so I'm going to use the division property of equality because this is multiplication. So opposite of that would be division. So I'm going to divide both sides by 3, because whatever I do on one side of the equation, I've got to do exactly the same thing on the other side of the equation. All right. So then this and this is 1, right? And so what I'm left with is x plus 2 is equal to negative divided by positive is going to give me a negative quotient. So this is going to be negative, and 18 divided by 3 is 6. All right. And now it's a one-step equation. So this is x plus 2. So the opposite of plus 2 is going to be minus 2. And so therefore, I am going to subtract 2 from both sides of the equation. So this is minus 2 and minus 2. And then if I look at this, 2 minus 2 is 0. And then I have x is equal to same signs. So I'm going to add, and I get negative 8. So no matter which method you use, whether you use the distributive property method or you use the properties of equality method, we are going to end up with exactly the same answer. All right. So let's try some more examples. So let's say I give you 3x plus 5, and I'll put the same thing on both because we are going to use both methods. So 3x plus 5 is equal to 45. Okay, x plus 5 is equal to 45. So we are going to use both methods. So let's start with the distributive property first. And then if I look at the distributive property, I know that I have to multiply each term outside with the term outside, each term inside. Okay, so 3 times x is 3x. Okay, and plus 3 times 5 is 15 is equal to 45. Okay, and now we have this two-step equation. Again, we are going to follow the inverse operation of PEMDAS, and we're going to do the addition part first. So we are going to do the inverse of addition, which is subtraction. So I'm going to subtract 15 from both sides of the equation, because whatever I do on one side of the equation, I've got to do exactly the same thing on the other side. So minus 15 minus 15. All right. And so I get 15 minus 15 is 0. And I'm left with 3x is equal to, and if I do 45 minus 15, I get 30. And now it's a one-step equation. So 3x means 3 times x. The inverse operation of multiplication is division. So I am going to again, on both sides, I'm going to do the same thing, which is using the division property of equality. And I'm going to divide both sides by 3. And 3 divided by 3 gives me 1. Okay, and so 1 times x is x, and 30 divided by 3 is going to give me 10. So this is how I simplify. Okay, and you can check the solution by substituting this value back. So if I'm saying x is equal to 10, all right, so this would be what? This would be 3, which is 10 plus 5 is equal to 45. Okay, and then if you're checking the solution, you can easily see that 3 times 10 is 30 plus 15, because 3 times 5 should equal to 45. And what is 30 plus 15? It is 45, right? So therefore that is correct, and that's how you check your solution, by putting the value that you find for the variable back into the original equation, and then check whether it is going to give you the correct balanced equation on both sides or not. Okay, so now using the properties of equality, we have written out the equation, and we know that this is multiplication. So opposite of multiplication is going to be division. All right, opposite of multiplication is going to be division. So I am going to divide both sides by 3, because in an equation, whatever I do on one side, I have to do exactly the same thing on the other side. And so 3 divided by 3 is 1. Okay, and so then I'm left with x plus 5 is equal to, and 45 divided by 3 gives me 15. And now I have a one-step equation. So opposite of plus 5 is minus 5. So I'm going to subtract 5 from both sides of the equation. And so I'm left with 5 minus 5, which is x, is equal to 15 minus 5, which is 10. So as you can see here, over here, distributive property method or properties of equality method, we will end up with exactly the same answer. So let's try another problem, this time with subtraction. All right. So let's say my question is 5n minus 2 is equal to negative 30. Okay, so I'm going to use both methods, the division property of equality, as well as the distributive property, again, to show you that doesn't matter. I will always end up with exactly the same method, with the same answer or the same solution, no matter which method you're going to choose. Okay, so if I'm using the distributive property to solve this, what am I doing? I am again going to take this number and I'm going to multiply with each term inside. Note that this time there is a minus. So you want to write minus here so we don't make a mistake, and we don't automatically assume that it's addition. So that is the biggest thing. So make sure you write the minus over here, minus and here. 5 times n is 5n minus 5 times 2 is 10. Okay, is equal to negative 30. Is equal to negative 30. All right. And now again, it's a two-step equation. So as we can see, opposite of minus 10 is going to be, or the opposite inverse operation of, negative or minus is going to be addition. So instead of subtraction now, we are going to do the addition property of equality. And I am going to add 10 to both sides of the equation, and then 10 minus 10, opposite signs, it gives me 0. So I have 5n is equal to, now look, we have opposite signs. So we take the absolute values of each. That means I'm going to do 30, because absolute value of negative 30 is 30, and I'm going to subtract the absolute value of 10, which is 10. So 30 minus 10 gives me 20, and the sign in front of the bigger number is going to be negative. So negative 20. So now I have one step equation, And so this is multiplication, and opposite of multiplication, I'm going to use the division property of equality. And I am going to divide both sides by 5, and 5 divided by 5 gives me 1, and 1 times n is going to give me n is equal to negative divided by positive is going to give me a negative quotient, so negative, and 20 divided by 5 gives me 4. So n is equal to negative 4, and this is the distributive property method. Okay, let's try the division property of equality over here. So that method also, and I can see that I am multiplying with 5. So the opposite or the inverse of multiplication is division. So I am going to do division, divided by 5. Whatever I do on one side of the equation, I've got to do exactly the same thing on the other side of the equation. 5 divided by 5 is 1, and then I'm left with n minus 2 is equal to negative divided by positive gives me negative. So minus, and 30 divided by 5 is 6. And then the next thing that I have to do is do the opposite or the inverse of subtraction, which is the addition property of equality. And so I am going to add 2 to both sides of the equation. And I can see that 2 minus 2 is 0, n is equal to, these are opposite signs, subtract the absolute values and give the sign of the bigger number. So 6 minus 2 is 4, sign here is negative, so n is equal to negative 4. Same answer, same answer. Okay, no matter which method you choose. um, let's do one with a fractional part. Okay. So let's say I have 2/3 n, 2/3 n plus 6 is equal to 10. Okay, so 2/3 n plus 6 is equal to 10. Again, I can use either method, but right now I am choosing to use the multiplication property of equality. If I have 2/3, and if I was doing division, I would do what? I would do the keep change flip, right? So I would do the inverse operation, and that means I am then multiplying instead of dividing with the inverse. So inverse of 2/3 is what? 3 over 2. Okay, because it's the flipped version. So now what I'm going to do when I have this set up like this, I am going to multiply each side of the equation. So I'm using the multiplication property of equality, and I'm going to multiply each side of the equation with the inverse operation, which is 3 over 2. Whatever I do on this side of the equation, I've got to do exactly the same thing on the other side of the equation. And now I can take the 10, it's a whole number, and I can convert it to a fraction by writing it over 1. 10 over 1, because isn't that exactly the same thing? So now if I look at 3, I can divide 3 by 3, I get 1. I can divide 2 by 2 and I get 1. So I'm left with n plus 6 is equal to, let's see, can I simplify anything from numerator to denominator? Absolutely. I can simplify the 10 and 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. And so I'm left with just 5 times 3, which is 15, over 1 times 1, which is over 1, which is actually 15. And now it is it is a one-step equation, and I'm looking at the plus 6, which is attached to the variable. So the inverse of addition is the subtraction property of equality. So I am going to subtract 6 from both sides of the equation to maintain that balance. And so 6 minus 6 gives me 0. I have n is equal to 15 minus 6, which is going to give me 9. So n is equal to 9. Okay. Um, and you can always check your answer by writing the original equation. So my original equation was, so if you're checking to make sure that you have the correct answer, you have 2/3 n plus 6, and we said, and then you're going to just is equal to 10. So this was my original equation. And so now what I'm doing is I've already calculated that n is equal to 9. So I'm going to substitute the value, and I have 2/3, and I have 9 plus 6 is equal to 10. Okay. And then when I'm looking at this, absolutely. What is 9 plus 6? If I say 2/3, all right, I can always do what's within the parentheses first. So this is 15 is equal to 10. So 15 over 1. And then I can simplify. This is 3 times 1, and 3 times 5 is 15. What is 2 times 5? 10 is equal to 10. So that is the correct solution. Okay. Um, so to learn the two-step equation, so we have the arithmetic method and we have an algebraic method. So let's talk about what that means. All right. So we have an arithmetic method and we have an algebraic method. All right. So let's, using only numbers and operations. So if I only have numbers and operations, operations are like PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction. Those are the operations. So when I only use numbers and operations, it is going to be the arithmetic method. But when I use numbers, operations, and variables, so variable again is any letter in the alphabet, A through Z, that is representing a number. So when I am, using numbers, operations, and I am using a variable, that is an algebraic method of solving. Okay. So let's say we talk about a problem, and we say that Mackenzie drives the same distance to and from school each day. Okay. So, same distance from school. She also drives 1 3/4 miles round trip each day to go to the library. During a 5-day school week, Mackenzie drives a total of 50 miles. So we're going to write and solve an equation to determine the total distance to and from school. So if I talk about in words, about this, all right. So what I basically said was 5 times the total distance. Okay, 5 times the total distance, and equals 50 miles. Okay, equals 50 miles. All right. And so we are going to take a variable, which would be d, to represent the total distance to and from school. So the variable that I'm going to use, d, is the total distance All right. To and from school. To and from school. Okay. Now, so the total distance that she's driving each day would actually be what? It would be D plus, and we said the distance was 1 and 3/4 miles round trip each day. Okay, so D plus 1 and 3/4 is the distance she drives each day. Each day. Okay, so now I'm just going to show you with a bar diagram to see the number of miles she is driving, because it's 5 times in the week, right? So if I just show you a bar diagram, okay, so we have the total distance is what? 50 miles. Okay, 50 miles. And then I am going to take 5 different bars. Okay, so I'm just going to do this. 1, 2, 3, 4, and 5. And this total amount is 50 miles. And each day, what did we say? It was D plus 1 and 3/4 miles driven each day. Okay, so D plus 1 and 3/4. D plus 1 and 3/4. D plus 1 and 3/4. I just wanted you to get a visual. 1 and 3/4, D plus 1 and 3/4. Okay, so over here is basically miles driven each day. Okay, and so we talked about the 5 different days. So what would my equation be if I'm looking at this? Okay, so 1, 2, 3, 4, 5. So if I'm writing out my equation to solve this, okay, I can see that my equation is going to be 5 times both D and this number, which is 1 and 3/4, right? And that is equal to 50. So just looking at this bar diagram, I can easily see why I have this equation written out like this. All right. So we are going to solve this, and let's start with my method of solving the equation. And if I have written out this equation like this, I have 5D plus 1 and 3/4 is equal to 50. All right. Now, 2 ways that I can do this. Once again, you can use the division property of equality. You can use the distributive property. But I'm just going to use the division property of equality right now. So if I'm looking at this is multiplication. So the inverse of multiplication is division. So I'm going to use the division property of equality, and I am going to divide both sides by 5. Both sides by 5, because whatever I do on one side of the equation, I've got to do exactly the same thing on the other side of the equation. 5 divided by 5 is 1. So then I'm left with D plus 1 and 3/4 is equal to 50 divided by 5, and that gives me my 10. Okay, and then I can see that I have got to, this is addition, so I've got to subtract, use the subtraction property of equality, and I am going to subtract a 1 and 3/4 from both sides of the equality of the equation. Okay, and so I am left with D is equal to 1, is equal to 10 minus, if I'm regrouping this, Okay, I would end up with 8 and 1/4. 8 and 1/4. Okay, so and that is basically the distance to and from school is 8 and 1/4 miles. Okay, and that is my answer. Um, so let's just do one last problem. Jamie and two cousins. Just, yeah, let's do this. Okay. So, Jamie and two cousins received the same amount of money to go to a movie. Each boy spent $15. Afterward, the boys had $30 altogether. Write and solve an equation to find the amount of money each boy received. So, first in words, three times the amount of money, three times the amount of money um, each boy has left. Each boy has left um, to spend equals $30. Equals $30. Okay, so those are the words. If I am writing the variable, I am just going to write m. So for the m is going to this is m is representing the amount of money each boy received. Okay, so money each boy received. So that is what you know m is going to stand for. So m minus 15, m minus 15 is the amount of money each boy has left to spend because they've already used up that 15, right? So m minus 15 would be what amount of money each boy has left to spend. All right. Now, so the equation would be, since we're talking about three boys, all right, because Jamal and two cousins. So that's a total of what? Three children, right? So the equation would be 3m minus 15 is equal to 30. Is equal to 30. So the next step would be to solve the equation. And I am again going to go ahead and use the division property of equality. So 3m minus 15 is equal to 30. And so, this is multiplication. Inverse operation would be division. I'm going to divide both sides by 3. Okay, 3 divided by 3 is 1. So I'm left with m minus 15 is equal to 10. Okay, and then as I can see now, I have a one-step equation, and the opposite of minus 15 would be the addition property of equality. I am going to add 15 to both sides. So plus 15 plus 15. Okay, and then 15 minus 15, this is going to give me 0. So m is equal to, what is 10 plus 15? That is 25. So this basically tells me each boy received $25 in the beginning. So again, it's nothing but a two-step equation. All right. So once again, that is lesson 7.2. Again, two-step equations. The best ways to actually solve two-step equations, you can use, of course, the distributive property, or you can use your properties of equations of equality. and that is basically using the inverse operation. And then the arithmetic method, where you're not using any variables. I mean, you can just do this straight up, trying to do it without any variables. The algebraic method I showed you more, because you are giving a value to each variable. So you do have a variable, you have numbers, and you have operations in the algebraic method. But then that's how we write and solve two-step equations in the format Px plus Q is equal to R. Have a fabulous day, y'all.